Welcome back to Wickerson Studios. I'm continuing with this first script, which is called Curve 001, and it is very specific to the curve point object menu list, which occurs in Rhino right off the bat. Point objects, single point, multiple point, closed point. I skipped drapes points because I use drape over in Rhino for dealing with draftable forms and making kind of blanket forms over shapes. Plus, it's a more complicated script that I don't think we needed in the basic grasshopper. Marking start curve, marking start curve end, marking the foci, which I chose to use in ellipse, and dividing the curve by length and by number are good ways to begin. Because over here in the curve menu, as we think of that last division, there are many ways to divide curves. So yesterday I went through, and you can see the organization is the title, Rhino 7 Education Lab, GH Basic Curves, Rhino Menu Bar, Curve, Point Objects, and then you can see the single point, multiple points, Rhino Commands, Curve Closest Point, and then I've extended this to finding using the curve node over here in analysis, which is endpoints. That will give me my mark curve start, my mark curve end, and then I found my foci by using the ellipse tool, which generates the foci in both ones. You don't have to script it in any language. And then I chose the length of segments and the lengths of the number of segments, which are two ways of dividing. I provided all my parameters over here on the left in these scripts that you'll need, and I've actually labeled them length, radius, count. The Boolean toggle are actually the Boolean toggle is actually for finding kinks and splitting at kinks in the curve, but I don't have kinks in my curve. The parameters over here are x, y, z, and the radius, and you can play through kind of these small purple scripts to get to these Rhino commands, to get to these geometries, and there they are. So you've generated a few sets of points. Now the reason they're not points and they're visualized a little bigger is this play sandbox is where I take points and I give them a little more volume through using spheres. I still have my panel tools here and my param viewer to check out the data structure. You'll see we're starting to deal in some pretty complex trees because we're dealing with different lines. And you can see that I am finding ways throughout here to find the marked ends of the curves at each side. And so what I decided to do when I was all done that, the basic script being this section, this guide will help you take the curve point objects from single point to divided curve number of segments into Grasshopper and be able to play with parameters, generate geometries from commands that are actually nodes and components in the Grasshopper vanilla tools, mostly in the curve tool. So those are here. And then this is the geometries that are output, the points, the data, panels related to those points, and then a visualization of just spheres and planes. So you don't really need anything too complex like that. But you can see that I put on different radii to make for different visualization. Most people I find beginning, at least in my sculpture digital classes, need a visualization so they can start to interpret what some of these panels and data mean. But when you start to shift your mind from here over to here, you're starting to work computationally. So what did I do? I set up some new parameters, and I'm going to start making some bigger sandbox scripts. My goal is to get people to make a dozen to 2 dozen nodes into a pretty complex script so they can control the geometry and understand exactly what they have available to them. What I'm going to do here is go into display, which is common practice. Plane size is set too high. I'm going to bring that down to 2, hit enter, and have a much smaller plane of where things are. And you can see my model starts to look a little more pleasant. All I've got going on here is the turntable command, which is making this spin, which I like to visualize and know how big my scripts are. This could definitely work faster. This script actually generates these pipes. And I've got a couple of sliders on here, the bottom one being the easiest, an enumerated cap from no cap to rounded cap. Rounded cap kind of looks nice with the spheres, so I'll leave it. I have the radii control on those, and even in turntable it's moving pretty fast. And I have the amplitude of those lines. And you say, well, how are they made? The amplitude of those lines, and I usually read my script from back to front after I generate it. And these are playful to give you some more complex geometries and scripts to play with what you found out about this basic introduction to curves, point objects, Rhino commands, all the way through to dividing by segments. So that pipe tool, which you could very well go into surfaces and use variable pipe, you could use subdivision pipe, which really doesn't matter because none of the lines are touching each other or intersecting. But yeah, I usually use that whenever my lines get more and more complex. I use that wonderful algorithm, the multi-pipe tool. The other tool that I've used that got me interested in that is the variable pipe. You have to be careful with the gene pool, how to set your radii and your count correctly, which I'll do in later videos. Right now it's pretty simple. The lines being generated are these lines, and they're coming from these points and these points. Well, these points and these points are moved points with a vector, with an amplitude, which is controlled at the start, which we took a look at. So this point and this point are basically being drawn together. One is moving in the negative direction, and one is moving in the positive direction, away from the surface evaluated normals. And in order to get to those evaluated surfaces, I had to reparameterize my initial surface, which I can pull in here and grab a surface component. And what I like to do is just relay and then Control-Shift, detach, Control-Shift, detach. And you can see the surface is this one. It's coincident with another form. That's a nice way to see a surface. So I'll just leave that one on like that. I usually use containers to visualize throughout scripts, and that's about it. I don't really import anything. It's been reparameterized 0 to 1. So what happened here? One of the most common things that happens, and I will go in here and call it remap, which is one of the most common remap with bounds and domain. And what you have to do is, I'm going to pop this in here, add to group. You have to take numbers, which I actually, now we have to kind of go the other way and back to the remap so we can make sense of this remap, which I think is a very powerful tool. And constructing and deconstructing vectors allows you to do that. This is one of the most complex components, which I love the most, the evaluate surface. We'll get to that a little later as we get closer and farther into surfaces. The nodes are pretty powerful over in Grasshopper. So let's go back to what we had. We had geometries. And these two geometries are basically, let me think about what I had. I pulled them back to these two geometries, which ended up being these visualization nodes. They were 2 points on the surface currently. And what I did was I found the closest points of those foci, which were the foci of the ellipse I was using. So that's exactly what they were, and they should be tucked in there. They're just hard to find in this model, or a little hard to see without the visualization. But those two foci then have closest points to every one of those curves that I was bringing out before. So once again, it's a nice practice to visualize what you're doing for people. This is obviously more complex, but that's why the playground can be kind of fun. Relay, Control-Shift, over into here and over into here. And now you can see that I have these curves. So I'm dealing with a list of items, a list of curves, to find out where those closest points are on each of those curves. So I'm going to take this one and pop it in here, add to group. And so there's many points of which. And then I do flatten that data because I want to have a dispatch of one side and then the other side of those curves. And at this point I'm going to take off my turntable. So technically I have two lists of points, and I can find the closest points to those curves. So these two foci points, which I had shown earlier, where are their closest points to these curves? Well, it's several points. And I dispatch those in the two lists so you can see the line between what I've generated. But then I just want to get the points. I want to deconstruct them. I don't want to worry about the z-axis because I want them to be particular to the surface I'm dealing with. This surface. I don't need the z because I want it on that surface. And I remap that value, which you'll see the x value and the y value come up with all these numbers that reach outside 0 to 1. But a surface reparameterized will go from 0 to 1 in the u and 0 to 1 in the v direction. So I will set a bounds between that number and find out what the range of that was, what it once was as I hover over it. And that range is from -2 to 3, but I could set that in a target domain, both of them, between 0 and 1. And it defaults to 0 to 1, but I'm going to hard code that in. So 0 to the domain start, and copy it and make, actually it's probably faster just to do it the other way, 0 to 1 here. So the domain is going to push those numbers between 0 to 1, and then when I put them back into a point, they're relative to this size, but when I reevaluate that full surface with the 0 to 1, I end up with these points. And so they're going all the way around it, back to the sides as to where they are as they come up. So with that data, I'm able to push and pull those points in different directions from an amplitude. And so the script is a little clumsy. It's not clumsy, I think it's well built, but it's a little hard to follow as to what's happening because I use this kind of remapping balance tool in between. But you're starting to take apart points and put them back together to really gain computational control. I think it's a great introductory script to start to try and set your goals on understanding, because if you can deal with points and you can deal with surfaces and evaluations and vectors and amplitudes, you're going to have a really nice way of keeping control in your own head. So I put my parameters here, I put my geometry nodes here, and the script is kind of tucked between. And once you find out how this kind of works, what's interesting about a thing like Grasshopper is you can cut and paste that, you put it down here, and if that is something you want to repeat several times, there's a wonderful tool that you go in here, hit your scroll button, or you can just type in cluster. But I'm having a little bit of trouble with my mouse. Go up to this cluster node, and you've clustered that entire node as a function, which runs from this to here, and you're able to, as you can see, oh, that's interesting. Let me go back a second. I've got two. Let me remove from group, and I'll just add this one to group. There we go. So you can see that I have this end geometry through this cluster with a couple of sliders and parameters that will drive that. So you can cluster that into a cluster. I'm not going to do that because that's a little more advanced than what we need to do. So I'm going to come back, explode my cluster, not copy it, leave it as one version. So go into here and play around with that first section of curve, point objects, know how to do it in Rhino, but also know how to translate all of that into here. And you'll find as you start to play, there's a lot more to play with, like the divide nodes. Somebody's customized all these frames, customized all these analysis tools. We're only touching on a few of them because we're going to duplicate the ones that are in the Rhino environment into the Grasshopper canvas. And then I'm going to have a playground, and what I would suggest is jump into the script, which will be GS Basic Curve 001 on my GitHub, and make your own. Get in here and play and make your own scripts that might actually come in. And this is how I'm introducing Grasshopper to students that are just new to Rhino. Okay, and just to end it, recommand, turntables back on, and change your speed. If you're tired of looking at it that way, I like this little tool. I've always liked it. Spin it back the other way. And realize that this type of control will help us as we get farther into sets, masking and offsetting, and dealing in data. Let me think. What I used to call it, I use it very rarely. The path mapper. We'll end up getting into split tree and doing a bunch of information with this and controlling it. All right. Thanks very much for watching. Michael Wickerson at Wickerson Studios.